So let's take a look at vectors. So to give a basic intro on vectors, let's say we have two vectors A and B. So a vector has two main parts. It has its initial point, or its starting point, and then it has its terminal point, or its end point. So if we were to add A plus B, the starting point of the second vector B is going to attach to the terminal point of the first vector A. So the starting point of B will attach to the terminal point of A. So when we combine the two vectors, we'll get something like this, where we have A's right here, and then B, the starting point, will connect with the terminal point. And so that will be B. And so when we combine them, we'll get a new vector, and that vector will be A plus B. So now let's say we have instead of A plus B, we have A minus B. Well, we can change this and think of it as adding A plus a negative B. So a negative vector of B. So we still have A here. This will be vector A. But then if this is positive B, then negative B will just go the other direction. So that will be negative B. So if we add negative B here, there's negative B. So then the new vector, this one, will be the result of A minus B. So let's say for number 1 we have three vectors, u, v, and w, and for A we have to find u plus v. So obviously we're first going to start with the first vector here. So u, we're just going to copy that down, and then we're going to add v. So remember, the initial point of the second vector, so the initial point of v, will connect with the terminal point, or the ending point of the first vector u. So it's going to look like this, approximately. So the new vector u plus v will be right here. So now let's find u minus v. So I can rewrite this as u plus a negative v, because we're basically adding a negative vector v. So we can start by drawing u, and then if this is positive v, negative v will just go the opposite direction. So this will be negative v. So if we go ahead and add a negative v, the starting point of the second vector will connect with the terminal point of the first vector. So negative v will look something like this. So this is the resultant vector of u minus v. So now let's say we have to find v plus w. So we're going to start with the first vector, v. We're just going to draw that right away. So we got v right here. And then w, it goes straight up. So once again, the initial point of w is going to meet with the terminal point of the first vector, v. So it's going to look like this. So that's going to be w. And so the new vector created, if I move the v over to the other side, the new vector created will be right here, of v plus w. So now let's say we have w plus v plus u. So we're going to start with w, which just goes straight up, like so. And then let's add v. So the initial point of v, the starting point, is going to meet with the terminal point of w. So we can go ahead and add v, like so. And then we add finally u. So the starting point of u is right there. We're going to add that to the ending point of v. So it's going to look something like this. That's going to be u. So then the resultant vector, w plus v plus u, is going to be right here. So this will be w plus v plus u. Now before I go on to the next set of problems, I just want to talk about how vectors are written. So vectors are written in component form. So let's say we have vector A here, and I'm going to draw it in a coordinate plane. So let's say vector A has an x value of 3 and a y value of 2. So vector A will be written as 3, 2. So it's not going to be in those regular parentheses like in coordinates, but it's going to be written in these greater than less than inequality signs. And the reason why that is the x component is 3 and the y component is 2. So if we look here, the x component go 3 in the positive x direction and then up 2 in the y direction. So that's why it's written like so. So let's say for number 2, find vector A with representation given by the directed segment AB, and then draw the vector starting at the origin. So for letter A, we have the point A, which is at 2, 3, and point B, which is at negative 2, 1. So let's go ahead and start by drawing out, or graphing the points and then drawing out the line segment. So at 2, 3, this is going to be point A, and then point B is going to be at negative 2, 1. So that will be point B. So this is the line segment we're given. So in order to find the vector A, now remember vectors are in component form, so a simple formula to use here, given 2 points, is we're going to take the vector A is going to be equal to x2 minus x1, and then comma y2 minus y1. So that will be the given vector A. So in this case, A will be equal to x2, which is negative 2, minus 2. That'll give us negative 4, comma y2 minus y1. So the y2 would be 1 minus 3, which will give us negative 2. So A has the components negative 4, which is the x component, and negative 2, which is the y component. And you can also double check that in the graph, because notice we go to the right 1, 2, 3, 4, and then we go down negative 2. Or we go to the left negative 4 and we go down negative 2. So that matches the components of A, vector A. So now all that's left to do is to draw the vector that starts at the origin, so its initial point is at the origin, and it needs to have the exact same components of negative 4, negative 2. So I'm just going to start at the origin and go left negative 4 since it's negative, and then go down negative 2. So the vector A will look something like this. So notice it starts at the origin, but it's basically parallel to the line segment AB because it has the same components. So let's say now point A is at coordinates negative 1, negative 1, and point B is at coordinates negative 3, 4. So if I were to go ahead and draw this, negative 1 would be right here, and then negative 3, 4 would be up here. So this will be point A, and this will be point B. Now if I were to draw the vector, or actually find vector A first, remember the component formula here is x2 minus x1, comma y2 minus y1. So B is the second set of points and A is the first set of points. So we'll take the second, or x2, which is negative 3, minus x1, so negative 1, which is the same thing as adding 1. So negative 3 plus 1 will give us negative 2. And then we take y2 minus y1, so 4 minus a negative 1, or in other words 4 plus 1, which is 5. So that is the component of vector A, or those are the components of vector A. So now if I were to draw the vector starting at the origin, so the x component is negative 2 and the y component is 5. So I'm going to go to the left negative 2 and then up 5. And so that will be vector A. So now let's say for letter C we have to find vector A just representing the given segment AB. So notice both of these are in three-dimensional coordinates. So instead of just having, for the formula, x2 minus x1, comma y2 minus y1, since we have the z coordinates, we also have to include z2 minus z1. And that will be the formula to find vector A. So vector A will be equal to, we take first x2 minus x1, so 2 minus 0, which gives us 2, comma 3 minus 3, so that will give us 0. And then finally we have negative 1 minus 1, so that will give us negative 2. And so that is vector A in component form. So let's say for number 3 we have to find the sum of the given vectors and illustrate geometrically. So for A we have the two vectors. The first one is 3, negative 1 as its component form, and the other one has negative 2, 4 as its component form. So whenever we add vectors, we're just going to add the x components, so x1 plus x2, and we're also going to add the y components. And that's how you sum or find the sum of the given vectors. So for the x component, we're going to take 3 and add negative 2, so we'll get 1. And for the y component, we're going to add negative 1 and 4, and so we'll get 3. So this is the resultant vector, which has the components 1, 3. So if I were to draw this out on a coordinate plane, the first vector gives us 3, negative 1, so its x component is going to be 3, and its y component is negative 1. So this is what it's going to look like. And the second vector has an x component of negative 2 and a y component of 4. So we'll go negative 2 to the left and then up 4. So this is what the other vector looks like. Now remember, the initial point of the second vector, which is right here, must meet with the terminal point of the first vector. So we're going to go ahead and combine those together. So if I shift this vector to the terminal point of the second vector, we'll get something like this. And so that will give us the new vector here, if I draw it in a different color, the resultant vector, which has the components 1 as the x and 3 as the y. So let's say for b we just have to find the sum of 0, 1, 2 and 0, 0, negative 3. So once again the formula. Now notice we have both x, y, and z components. So we're just going to take x1 plus x2, comma y1 plus y2, comma z1 plus z2, and that will give us the resultant vector. So the resultant vector is first take 0 plus 0, so obviously that will give us 0, and then we'll get 1 plus 0, which is 1, and then 2 plus a negative 3, or 2 minus 3, which will give us negative 1. So that is the resultant vector. So let's say for number 4 we have two vectors, a and b. So a has the components negative 4, 3, b has 6, 2. And first let's find the magnitude of a. So whenever we have an absolute value, remember that's either referring to the magnitude or the distance or the length. So let's say we draw component or the vector a. So vector a has the components negative 4, 3. Or in other words, its x component is negative 4 and its y component is 3. So vector a is going to look something like this. Now if I were to expand that out and make it a little bit bigger here, we have vector a. So its x component, once again, negative 4, and its y component is 3. So if I were to make this a right triangle here and label my x values, we can actually use the Pythagorean theorem to find what the magnitude of a is, because the magnitude is just going to be the hypotenuse. So obviously the hypotenuse is just going to be equal to the square root of x squared plus y squared. And so we have the square root of x squared, so that would be 16, plus 3 squared, which is 9. And that will give us the square root of 25, and the square root of 25 is 5, which is what the magnitude of vector a is equal to. So once again, in order to find the magnitude, we're going to take the square root of the x component squared plus the y component squared. So now in order to find a plus b, obviously we're just going to add the vectors, so we add the similar components. So a plus b will give us the resultant vector, which has the components. So we're going to add the x components together. So negative 4 plus 6 will give us 2, and then 3 plus 2 will give us 5. So that is the component of a plus b. So now in order to find a minus b, we're just going to go ahead and subtract the components. So a minus b will give us the resultant vector with components negative 4 minus 6, so that'll give us negative 10, and then 3 minus 2, which is obviously 1. Now in order to find 2a, all we're going to do, 2 is kind of like a constant or a multiple, so all we have to do is take the a components and multiply both the x component and the y component by 2. So 2a will just give us negative 8, 6. So now in order to find 3a plus 4b, let's go ahead and first find 3a. So all we're going to do is multiply the a components by 3. So 3a is going to give us negative 12, 9, and then 4 times b will give us 6 times 4, which is 24, and then 2 times 4, which is 8. So now if we go ahead and add those two vectors, so 3a plus 4b, we're going to get negative 12 plus 24, so it'll give us 12, and then 9 plus 8, which gives us 17. So now let's say for number 5 we have vector a, which has components 6, 2, 3, and vector b, which has components negative 1, 5, negative 2. So notice it has both x, y, and z components. So now in order to find the magnitude of a, now remember in the second dimension, when we had just the x and y coordinates, we could just take the square root of x squared plus y squared. Now since we have an extra component z, or the z component here, we have to add the z squared. This is going to be the square root of x squared plus y squared plus z squared. So the magnitude of A is going to be the square root of 6 squared, which is 36, plus 2 squared, which is 4, and then plus 3 squared, which is 9. So that will give us a square root of 49, which is 7. Now when we find A plus B, we're going to go ahead and just add the similar components. So x2, or x1 plus x2, so we have 6 plus negative 1, or 6 minus 1, which gives us 5. And then for adding the y components, we get 2 plus 5, which is 7. And then we can add the z components, so 3 plus a negative 2, which is 1. So now for A minus B, we're just going to go ahead and subtract the components. So for A minus B, we're going to take 6 minus a negative 1, or in other words 6 plus 1, which is 7. We get 2 minus 5, so negative 3, and then 3 minus a negative 2, which is 5. So that will be the components for A minus B. Now in order to find 2A, once again we're going to take A and just multiply it by 2. So 2A is going to give us 6 times 2, 12, 2 times 2, 4, and 3 times 2, 6. And then finally to find 3A plus 4B, we're going to take 3A, so 3 times all the components in A, so that'll give us 18, 6, and 9. And then 4 times all the components in B, so that'll give us negative 4, 20, and negative 8. So now if we go ahead and add those two vectors, we're just going to add the components, so 18 plus a negative 4, 3A plus 4B. So 18 plus negative 4 will give us 14, 6 plus 20, which is 26, and then 9 plus a negative 8, which gives us 1. Now before I go on to talk about the next set of problems, let's talk about unit vectors. So unit vectors are usually written as just u. And so let's say we have vector A. In order to find the unit vector for that certain vector, we're going to take just the vector's components and divide them by the magnitude of vector A. And that will give us a unit vector. And there are also 3 special types of unit vectors, and they're labeled as I, J, and K. So I is going to be equal to the vector 1, 0, 0. Those are its components. J is going to have the components 0, 1, 0, and K is going to have the components 0, 0, 1. So I is referred to the X components, J will be referred to as the Y components, and K will go with the Z components. Since the 1 is at the X component for I, 1's at the Y component for J, and at the Z component for K. And so let's say vector A has the components 1, 2, and 3. Then we can also write vector A as being equal to I plus 2J plus 3K. As the I represents the X component, and there's just a 1 in front of the I, so the X component will be 1. And then J represents the Y component, so there's just a 2 in front, so that will be the Y, and then obviously there's a 3 in front of the K. So let's say for number 6 we find the unit vector for 9, negative 5. So the unit vector once again is going to be equal to, let's just go ahead and call this vector A. So vector A is going to be equal to 9, negative 5. So the unit vector is going to be the vector A's components over the magnitude of A. So once again, in order to find the magnitude of A, that is just going to be equal to the square root of x squared plus y squared, if we only have x and y components. If we have a z component, once again, we're going to have to add the z squared, but we don't. So the absolute value of A, or the magnitude, is going to be the square root of x squared. The x component is 9, so squared that is going to be 81, plus y squared, which is 25. So that will give us the square root of 106. So the unit vector is going to be A. The vector A has the components 9, negative 5, and we're going to take that over the square root of 106. So we can also write that, since 1 over the square root of 106 is sort of like a multiple, we can also multiply that inside the vector's components. So we'll get 9 over the square root of 106, comma, negative 5 over the square root of 106. And that is the unit vector for vector A. So now for number 7, let's find the unit vector for 8i minus j plus 4k. So let's go ahead and call that vector A. So the unit vector, once again, is going to be a over the magnitude of a. So notice this is written in the unit vectors I, j, and k. So since I goes with the x value, 8 is in front of I, so the x component will be 8. Now j goes with the y component, and there's a -1 in front of the j, so the y component is -1, and 4 is in front of the k, so 4 will be the z component. So those are going to be the components of vector A. Now in order to find the magnitude, since we do have a z component, we're going to take the square root of x squared plus y squared plus z squared. So then that's going to lead us to the square root of 8 squared, 64, plus -1 squared, which is 1, and then plus 4 squared, 16. So that will give us the square root of 81, which obviously is 9. So that is the magnitude. Now, in order to rewrite the unit vector, we're going to take the components of vector A. So obviously we have 8, -1, and 4. And then we divide all that by the magnitude, which is 9. So we can also rewrite it as the vector, which has the components 8 over 9, comma, -1 over 9, comma, 4 over 9. So we can divide each of the components by 9 as well in order to find the unit vector.